maybe to discuss a little bit what are the known unknowns in crop impact projections. Basically, what is actually behind these projections that is maybe not not totally accurate, or could profit from further analysis along the chain of AgMIP models. So what we are trying show a few slides. So Roger will do is we're going to try to identify some weak points in crop growth modeling, at the same time as identify some weak points, and I will mention a few topics of improvement for the economic side, and how actually these two worlds are able to match each other in a better way, moving a little bit beyond the current situation. No, as you know, currently crop growth models, biophysical models, they do produce mostly yields, and those yields are taken up by some of the analysis that is done at higher scale level in economic models. And basically what you do is just shift the supply function in an economic model up and down depending on all the information of the crop growth model. But of course, there's a lot of nitty-gritty in here, and there's a lot of room for improvement. And I think we should discuss this today and try to find some elements that we can take up in the next years of collaboration. So without further ado, maybe Roger, you present the reviews.
Yes, thanks, Ignacio. So yeah, I think you pretty much explain everything, the objective. So I take some 10 minutes or a little bit less to show some ideas, to illustrate the discussion of the session. So I would like to start here by showing these 6 components. I think this somehow are the 6 components. Maybe I forgot one, or I'm not sure. But in any case, we took some time thinking, and I think those are the most important components of a cropping system. So here, the first one is, of course, crop. You have to define. And behind the crop is you have the biotechnology, the seeds, and everything that comes in, right? And you have the climate, the fertilizers, the land, to have land available or not, the labor, machinery, and technology. So those things are driven by market and policies, right? So when I talk market, I say mostly, and Ignacio is the economist, you can correct me if I say something that's not correct, but I think the most important component in the market is the price. So what's the price of those things when the farmer is taking the decision to what crop, where, when, and how, right? And policies also, in a way, can drive those decisions, because in a way, maybe there is a policy that's going to say you cannot use this amount of nitrogen, or for example, as there is in Europe, European Union, or you cannot use this type of crop, or you cannot use this type of genetics in here, or you cannot use land, and land has to be protected or not. So those things are, and in a way, those are driving the decisions of the farmers, right? And after that, the farmer in the end is going to decide how much, what's the size of the area, and the yield, right? Through those decisions, we get the final yield. So through yield and the area, you have the production. And through after the production, you transport it, you export, you bring to the market. You have what we call food availability, which could be called also food offer, like what's offered in the market. And then the market also has a demand, right? Sometimes you have a lot of food, not enough demand for one specific crop of food. Sometimes it's the opposite. And this balance between demand and availability, demand and offer, it's what gives the price in the end. And the price in the very end, it's what makes food accessible, sometimes you have things in the market, but you cannot pay for it. So then it's not accessible. And also you have the environmental impacts of it, right? You have the biodiversity impacts, you have maybe pollution, CO2 emissions, and it goes with lots of environmental impacts that we may have according to this diagram. So considering that, what actually the crop models do here, considering this photograph. So I think crop models, they are mostly focused on taking as inputs crop type, the climate, fertilizers, and some technology. For example, if you have a technology that's helping you to define which one is the best soil dates, for example, that is an input used for a crop model. And then it simulates through many process, the yield, and some environmental impacts. For example, CO2 sequestration or emissions could be simulated with some crop simulation models. Okay, but focus in climate, because climate is an input, and this diagram was shown already. This is a diagram for Alex, which is online with us. Here, in the IPCC report, he showed all the climatic impact drivers. So they have heat and cold, wet and dry, wind, and everything that is in brown here means there is an impact in agriculture. So you see there is lots of things that can impact agriculture. For instance, frost, cold spell, river flooding, or fire weather, and many other things that many climatic impact drivers that can impact. And what the crop models they actually do, that's a review we have done with different crop models for different crops. For instance, for wheat, here we have 31 crop models behind this diagram. So what this diagram shows is that 100% of the 31 crop models we have checked, they make drought simulation. Most of them, they make nitrogen. Maybe half of them, they consider heat impacts. But very little of them, very few of them consider heavy rainfall, pests, ozone, other nutrient pests, this frost, disease, wind, and waterlogging. The picture goes same way for different crops, as I showed here. So, which means lots of climatic impacts in crop models. So, in addition to that, we also only have crop models for few crops. I mean, robust crop models we only have for few crops, and there are many important crops like coffee, cocoa, that still doesn't have much related to crop model, right? So we also have to, go there. Our way to make it would be, we have some people from machine learning team here. A way to make it would be maybe to what we call use hybrid models, which is the field experiments. It's also a type of model, right? Because you are in a way in a small plot using that as a model of the entire thing. So that's also a model, So you can take field experiments, and the good thing about field experiments, I mean, that's the basis of we had discussed about more data, and so that's what's the source of data. It's that we can create those same conditions. For instance, maybe we have a situation that you have frost and after heat. In future we're going to have such situation, but we never had that in the past. You can create that in field experiments and feed that in machine learning. Then machine learning can learn this. I mean, with machine learning, it's easier to include more features. And that's what I want to say here. It's a simplified integration of a broad range of diverse climatic impacts. And then you can teach the crop model in machine learning and use that to simulate more experiments across various conditions and locations, which would save time and costs from new field experiments. So that's what we call hybrid models. That would be an opportunity maybe to improve our simulations for yield. Of course, we always have to put that in open data repositories, otherwise it would be complicated. You have to always have those data simulations available, then people with commitments to use. And just to say some things about economics, and most of the examples I give here is for Brazil because that's the country I know more. But here's actually the wheat production loss globally. That's from calculated from the FAO data. And you see, on average, every year there is 20 million tons of wheat being lost because of climatic diverse impacts. And in some years, for example, 2007, you can reach 40 million tons of wheat loss. What happens, for example, in years like 2007, what happened this year specifically, that the wheat price that was quite stable since in 1959, it's had a huge spike. So it jumped from close from 100 to $400 per ton. But the interesting thing here is we had something, I go one slide back, in 2003 and 2004, 2 years consecutives, we also had very similar loss, 40 million tons in 2 year consecutives. And then nothing really happened to the price, you see? Nothing really happened to the price. So it's not that simple to model price spikes, right? That's what I want to mention. And then you had another price spike, for example, for loss that you had in Russia in 2010, 2012, and then with COVID and the war in Ukraine recently. And I mean, price is very important because, as I said, it drives the availability of food in the end for us, the consumers, to buy. But also, there's huge impact on the behavior of the farmer, right? For example, here we have a relationship in Brazil. And Brazilian farmers are very sensible to wheat price. So you see here, related wheat price against wheat production in Brazil, you see that the wheat, only because of the price, the wheat production can jump from 4 to 9 million tons in Brazil. So it's a huge difference. And also bring to Brazil, Brazil is a big importer of the wheat. And here what I want to say is that we can model the global wheat price, and maybe we can have a model that model the spikes, and that would be very good. But for example, in Brazil, and this happens in many other countries, here you have the green line that shows the wheat price in Brazil, and the blue line, the wheat price in the world. When you make the relationship of these two lines, you see that in Brazil, the wheat price can be up to 80% higher than in the world because we are buying, right? So we have to pay for transportation and so. And especially, for example, in years like 2012, in which Brazil couldn't produce much wheat in that year, the price really goes up. So we also have to have a model to simulate this local price. And another example for Brazil that's more recent, that's for south of Brazil for soybean production. That's quite important because that's it's a combination of yield and price and costs production. So that's what's happening with the production of soybeans south of Brazil. You see, I mean, there is quite a variability here, but in the last 5 years, this was quite variable. So we have Mauricio here. Santiago, they know the situation in Rio Grande do Sul is actually the state of Mauricio. So in 3 out of the 5 years, the production was one of the lowest in history. In that, in this specific states in south of Brazil, it's a very important state. And the production costs to produce in the entire state is this graph here. So it's consistently since 2000. Going up, but since COVID, it just jumped from 15 to 50 billion reais. You always divide by 10, by 5, more or less, then you have in dollars. So it means it's $10 billion to produce in this state. And that net revenue they're having because of this and this, it's in here. So they have 3 consecutive years that they have negative revenue in the state. And if you sum these 3 years, it's 90 billion reais, which is $15 billion they accumulated in debts in 2 years. So they are getting very close to a collapse in this production system. So we want to model it. So, and here I have, I think the main message is, okay, you have crop models, and I don't want I'm not here saying that the crop models has to do more than huge simulations, but probably we as a team, using all the modeling approaches and so, you have to do what I wrote here, crop system modeling approach. So you have to model the crop system, and then you can maybe get to a point that you can simulate all those impacts and so. For example, crop models, they have underestimated impacts of climate extremes. So we have to do that. They have to include more crops. There has been modeling more environmental impacts, pollution, versus CO2, and so they need to include the land use an issue. All the modeling approach, for example, they have to model the harvest decisions. They have to model policies impacts on food availability, include price, finance, and wars, for example, and they have to model new technology impacts on food availability. Also, economic modeling, maybe can improve by modeling of price spikes, including endowments and farmers' decisions like water, nutrients, and quality, and modeling the how policy incentives to adopt technology for change. So here now I leave some questions that we try to respond collectively, and that's a talking I open to discussion on.
Thanks a lot for you. Who wants to start?
Maybe Alex can give some comments, I think.
You want to intervene, Alex?
Yeah, I'm here. Can you guys see me now and hear me?
Yes. Yes.
All right. Well, yeah, thanks for getting us started, Rogerio. Yeah, I think one of the things that we have to recognize as we're building all these tools is our limitations. And that's part of what motivates new science, but it's also something that we have to consider as we're presenting our results to the policymakers who might think that, you know, when we say we modeled the crop, that means we did everything, right? And it's not necessarily that true. So in the climate community, we have developed something called climatic impact drivers, which are that table that Rogerio showed, things like drought and heat waves. But of course, the future of agriculture also has a huge number of non-climatic impact drivers, other things that are driving it, whether it's policies, new markets, new technologies, shifts in trade, new systems, all of these things that can come along. So one of the things I was hoping we would get to kind of in today's conversation is, can we identify what these other things are? And maybe I would ask you to role play and say, if you were giving your crop model results to the leaders of the state that Rogerio was just talking about, or to a policymaker in your country, what are the things that would make you nervous about knowing that your results are somewhat incomplete? And how could we augment what we're currently doing to directly address those additional issues? And maybe some of those things could be a low-hanging fruit in terms of a model improvement that we think is possible. Another thing may be saying that we don't think we can model it, but we think we have a general idea of the direction and magnitude of the impact. So for example, if we think our models are not handling waterlogging very well, then there are parts of the world where waterlogging is clearly projected to increase, and our models are likely underrepresenting the damages that would follow. So that seems like a pretty logical pattern that we might be able to communicate. So if we could bound and scope and maybe even identify some ways of filling in these gaps, that would be a very productive session. Thank you.
Yep, good over.
Okay, my name is Santiago, from Brazil, DAPA. One thing maybe I have been missing, because I have maybe my first time at AgMIP, but I didn't see anything about weeds. And weeds are very important, especially for intercropping now. There we have very many approaches about people. Okay, if you do intercropping, what's the impact of the weeds? If you can simulate that. About specific about wheat, another problem that I didn't see anything is about the quality. the major questions in wheat in Brazil, Maurice is here, it's about the wheat quality impacts a lot the price of the wheat. And about the water logging, at least for Brazil, the major problems that to evaluate that we are having to coupling hydrological model. Otherwise, we cannot see the impact because last year was the major disasters in Rio Grande do Sul state that kills a lot of people. It was the high disasters in the state, but has to be about the hydrological model. It's not about the field, but about the it's almost always coupled with the hydrology of the reefs, and these causes the major problems, not in the plot. It's about we have to be coupled with the hydrology.
Yeah, thanks a lot. This was
Hi, my name is Mauricio Fernandes. I am also from Brazil, Brabant. I've been working with crop models for a long time. And one thing that bothers me most when I'm working and trying to calculate a model of using some application is soils. I think that we are missing what's happening with the soil. Okay, like the soil is just uniform, it's not uniform at all. What Rogério showed about this speaks in the productivity in soybeans, for example. Even under a big drought, we can see some fields that they're doing very well. Maybe the guys were just lucky to got shown there, but some cases no, it's just the way that they manage the soil. So I think that soil management, I think, is something we should improve.
Biology.
It's a whole. I totally agree that the land dimension is kind of missing in this. You see that nowadays. So we have all the crop role models, modeling yield, and then you have somewhere an economic model taking up these years, but we don't know anything about soil quality. So
yeah, thanks. Well, that actually also our topic. We run a model, the erosion productivity impact calculator EPIC, that was actually developed to simulate impacts of soil erosion on crop yields. And we run the model globally, but then we switch off the erosion because we don't know the exact management of this, as you said, cropping systems that we need to represent. But I think this is also an underrepresented crop loss. And my impression is that many of those losses we saw here are kind of related to shocks, but then the soil health would also be you could call it a slow onset crop loss, that you overuse the land with mismanagement, and you have crop losses over time simply by cultivating crops too long in the wrong way.
Hi, I'm Paresh from India. So I think if I talk about the South Asia, most of the stress events really is 100%, almost 100% irrigated. So the pre-stress acting is the heat, which is really well accounted in a lot of models. What we really miss is the kind of untimely rainfall damages, especially towards the harvest phase of wheat. That's something which is causing loss. That some of the production systems are so diverse at aggregate level that they don't make any big impacts, but at local level they are quite of distress issues.
Hi, I'm Jyoti Singh from Columbia University. My comment is for connecting two themes. One is the plot that Rogério showed about the processes that crop models have. For example, most of the crop models do have the drought process, and water logging is one of the most underrepresented process. But I think I attended some of the talks here, like one talk from Amazon. Drought was kind of highly underestimated. Drought impacts were. And I also attended one talk from Hattie Weber's session, and she was also saying that drought stress impacts are likely underestimated in the crop models, and also the model underestimate ET. So I think all these process, waterlogging, drought, ET, they're all like related process. They all have a common module like soil water balance module, or maybe photosynthesis or a canopy temperature. So I think it's not just about developing these process in isolation, but also engaging with each other, that what are the modules that are common for these stressors, and then maybe lead the improvement through that engagement.
I like the comments made by Alex related to these different drivers of these different elements that actually do have a strong impact on production. But I like especially the comment about augmentation. I mean, when you do an analysis for a country, I mean, it could be Embrapa, could be the USDA, and they ask you about, what will happen if we have a drought. Then you have to come up with an answer. Then you look at what is the information you have from biophysical models that can provide to you. And then you find maybe 3-4 crops, what you mentioned, in a fairly robust and good detail. But what do you do with the rest? We make assumptions. We take a C3 crop, we take a C4 crop, and then we just proxy that. My point is that we shouldn't be doing that. You know much better than us how to proxy a drought and a potato field than you know it for sure, because your model is going to give you a good, very good estimate for water stress in maize, this type of maize in this region, and you don't have this global grid model or this regional model for potatoes or for sugarcane. But when you do an analysis, how the agricultural system changes to a specific drought, you don't do only maize and wheat, you do all of them. And then this is not decision, this just explains to you how it feels on the other side. Then you have to do some assumption. You take the average of the two crops and then extrapolate to all the others. You don't do any drought on those crops because they might not be affected, or you just don't know and don't want to make a wrong assumption. So I think this augmentation of data is very important. Alex, this augmentation of data is very important to come to a more integrated system where economics play a role and crop growth models play a role together.
I'm hoping I can jump in from online. First of all, really good discussion and questions already. And I just want to call out a couple things. So we have, in various portions of AgMIP, had a more active pests and diseases team. Mauricio, I think I'm on one of your papers from years ago where we looked at wheat diseases in Brazil, for example. Those things come and go, and I think we may be better positioned to come back to it soon. The weeds are not exactly the same thing, but in many ways we can model them in a similar way in terms of competition for light and other resources and things like that. And we do now have an intercropping team that's beginning. I'm gonna share some other signs of hope here and suggest that we can keep building these areas. I think we have been increasingly trying to connect crops into broader landscapes like basins so that we could do hydrology modeling. And it's too bad Henrique couldn't join. Henrique is a postdoc with us from Brazil. I don't know if he's online, but he's been doing some of this work modeling with the SWAT hydrology model coupled with DSAT. We also, I think it's very interesting when we look at what the models do really well. We can probably, because we're crop modeling, experts, we can find things that they don't do well in almost every category. So, the ET focus that we've now seen for the maize team and the wheat team and the soybean team is really, really important, because we need to get that drought signal as close as we can get. The last comment about casting the models that we do simulate onto the crops that we do simulate onto the crops that we don't simulate is very, very important. I remember working with Daniel Mason DeCroze as part of AgMIP's coordinated global and regional assessment. And we were trying to make projections using the IFPRI model, which has something like 100 different commodities. And we were giving them 4 or 5 crop model results. So they were saying things like blueberries act a little bit like wheat. And of course, that is very, very big extrapolation. So one of our big challenges is to fill in more crop types, and that will allow us to have a stronger view on what's coming. So there are efforts in each of these areas. For example, we now have the simple model that we're using to calibrate to more crops. I've seen several presentations with the aqua crop model, really, 40 crops and things like that. Really exciting to see. And I think we need to keep going in this area. I just wanted to maybe motivate one more question, especially since we have Ignacio there. On the economic side, the way we think about future systems and future markets, I think we can become increasingly more sophisticated using some of the philosophies that we've developed within the RAPS process, the Representative Agricultural Pathways. And we might also ask not just how do we represent all these things, but can we actually take on a challenge of a more optimistic and a less optimistic extreme in terms of what different systems might look like. And sometimes we might learn by asking, if we're trying to project out to 2050, that's 25 years from now, what might we have been able to say about 2025 back in the year 2000? That's 25 years ago. Would we have been able to predict some of the things that are coming now? Maybe not, but there are people who specialize in trying to at least scope out and bound those changes. Thanks.
Yeah, thanks, Alex. Very valid questions. On the backcasting, it's a very complicated issue for economic models, where we try to do that from time to time and try to go back, maybe not as far, because you find yourself in situations where some markets are just not existing, and it's very difficult. But we do try to do ex post calibration of the models, always a little bit back in time. I think some of the digital models do go back 10 years, something like that. Yeah. Any more questions in the room? Maybe, yeah. Maybe I'd like to have you.
No.
Maybe I'd like to have some. I mean, maybe make another question. Currently, there's a lot more. We've been having these models for the last 10, 15 years in AgMIP, but when AgMIP started, maybe nobody was looking at carbon stocks, or maybe nobody was looking at biodiversity outcomes. Some of these things are kind of post-model analysis. There's biodiversity models that can produce relatively well estimates of biodiversity levels based on all the inputs that we get from a crop growth model. No? So basically on yields, on nitrogen, leaching, or on the amount of pesticides that are applied and so on. But what about carbon? Carbon is an input to the crop growth model. So soil organic matter, I guess, is one of the inputs. Are we ready these days also to report not only yields but also carbon stocks, for example? And this brings me also to one of the elements that I brought in the slides: pastures. There's some teams like IASA that are focusing more on pasture land globally, but these are now carbon pools, and now we are not only requested to feed the world, but to feed it in a way that we also are carbon neutral. So could we just break a little bit that glass ceiling and then go a little bit into this direction? I'd like to see your comments on this.
Yeah, good point. Me. Actually, models simulate that, right? And it's difficult to have. You have to measure over the field because the soil carbon stocks change a lot, depends of the farmers. One thing that I have been seeing that maybe it's fail about the part of the carbon in the models that most of those models by history, they were developing just to simulate 20, 30 centimeters. And now actually, for instance, as we mentioned, pastoral brachiaria, other crops, they have a root deep system that goes up to 1 meter. So there is a lot of input of carbon that agriculture is doing. And actually, it's putting carbon in a deep, and as more deep, more is the time of the decomposition of the carbon. So it's more valuable than the carbon in the first centimeters, where eventually, if the farmers do some change in the field, the carbon is going to release. So I don't know if you are prepared to that, because we know much less about that dynamic in those deeps, and assuming that the time residence of the first centimeter pools that dynamic, and assuming that it's the same in a deep with less oxygen, it's probably not true.
Yeah, to speak again from our experience, we are working a lot on Europe, and we are also modeling soil organic carbon for European projects. And our experiences basically with our model that is based on century, we can do it if we get enough long-term field trials to which we can calibrate both the biomass of the crops and the soil organic carbon dynamics. And this is, as always, the scarce part of the whole exercise, to get long-term field trials. We have very good information and can do multi-objective calibration of your different model parameters. And then we have at least enough trust to say with a specific management, we can expect an increase or a decrease if you don't do this calibration, and if you don't set it up right. The model can either predict an increase in soil organic carbon or a decrease simply based on your initial value. But if you get those things right, then we are at least happy with the direction. What we can certainly not do is anything in the direction of carbon credits. And that is so far quite clear. Everybody wants to have this information from models because it's the cheapest way. But we know neither biogeochemical models nor data-driven models can provide this so far. So it's really the scope. What does your stakeholder want to know, I think?
Yeah, so the title of this session is Known Unknowns, but maybe with making a list of all of the things we don't know, or the things that we know have not been included in our models, or those things that we know that we ought to include but haven't included. Okay, this could be an extremely long list. There is also, it seems to me, a more practical way to frame the question is it possible in these different models to add a level of uncertainty to the results? That's the practical result of these things that we know we haven't included in the models. So maybe that's a way of organizing this information about known unknowns so that it gives practical information about how good are the model results that we're providing.
My name is Peter from Australia. Yeah, I'm not sure if I missed the agenda, but practically what I faced previously was most of the models, including DSAT and AgMIP, they didn't include lodging response. So, for example, if you take TEF for Ethiopian crop, the nitrogen response of TEF is was a function of lodging. So, do you have any experience on this one? I don't hear anything on different. Anybody working in lodging or?
Yeah, there's very few in lodging. Very few in lodging. I mean, I know some attempts. I know some attempts of modeling lodging. Is it working? Yeah. And but I mean, it's in a way. We interpret it when we show that graph that for the missing components of a graph model. Lodging, it's a response to extreme event. So it's a response to waterlogging or to very strong wind or for something that's or a disease that's happening there, and then the plants So it's a response to that. So it's a no. But the crop models, they don't, the ones I know, they don't consider that, and I don't know any crop model that consider that. I know some modeling attempts of modeling lodging, but usually outside of crop modeling.
This is Alex online. I just want to jump in on that, and sorry if I'm over speaking anybody, but yeah, this idea of some of these things might be handled better outside of the crop model. So for example, we might run a simulation of the entire state of Iowa, and then later use a hydrology model or observations of flood to identify flood damages and impose a damage function on top of the yield outcomes. Iowa also was the site of a very famous derecho, which was a strong wind front that knocked over nearly all of the corn, all of the maize in 2020, and there was another one a few years before that. We can see that with our NASA satellites. So there is a data set potentially around understanding how those damages were put in place, and also which fields recovered. So yeah, very, very interesting for us to think a little bit more about that.
Yeah, and I think one interesting point there is maybe we have to define what do we need and what do we don't in crop simulation models. Or I mean, what do we need to include, what's mandatory, and what we can copy from outside. For example, using technologies, as you said, from satellites, or using machine learning. I mean, modeling techniques also for modeling some stress, and also from outside. Then adding some new penalties in different crop modeling, and also coupling. I mean, the results of with crop model from crop models with the economical models to, as I tried to explain in the beginning, to get some glimpse of the food availability in the end, what's really matter for food security, and so which are the points we want to get. So not necessarily we need to do everything with crop models. We have lots of modeling techniques and technologies, satellite, and maybe the question would be, how can we combine all those questions to better simulate the crop system entirely?
So with an eye on the clock, maybe I'll ask a provocative question. I think many people in the room are aware of the GGCMI study that Jonas Jägermeyer led with about 10 crop models. I think I heard maybe Christian's voice or somebody else who's GGCM modeler in the room. If we were to guess about whether those projections are overly optimistic or overly pessimistic, I wonder what a survey would look like in the room. So yeah, I don't know if I want to put people on the spot to vote optimistic or pessimistic. And from what I've heard this week, I actually think some of the estimations are that the wheat models may be too optimistic and the maize models may be too pessimistic. Some of those things are not necessarily universal. But I do think coming out of this conversation, there is room for us to have a commentary piece or some kind of broader AgMIP, sense of the AgMIP community around what is the best way to interpret the projections in light of what they do and do not actually simulate. Especially with IPCC coming, that would be a very good kind of line drawn on the ground that might also motivate funding to fill in gaps. So we started something like this. I showed Rogerio and Ignacio figures that I made prior to AgMIP10 in Costa Rica, which was 2018. We started a document like this, and I'm at least coming out of this conversation thinking that we should dust that off and update it, and then maybe update it every 3 or 4 AgMIP workshops just to keep the state of the science strong. Thanks.
Yeah, just to comment, I mean, the projections from the paper says that the wheat productivity is increasing by around 6%, if I'm not mistaken, between 6 and 10% globally by the end of the century. So is it optimistic? Is it pessimist? I mean, from the simulations done with different crop simulation models, what would be, how could you use those projections? So from adaptive for climate change, or so what do you think?
Can you say it again?
Yeah. I mean, I following the question from Alex. The projections from this GGCMI studies are, you can correct me, but I think it's around 6 to 10% increase on wheat yield by the end of the century. So it's projected increase in wheat yield by the end of the century. They use crop simulation models. You know that there are lots of extremes that are not considered. But the question is, what are the lessons from these projections? I mean, they are really happening or not? You don't believe in them, but what can you use? What can we learn from this projection from crop simulation models? Yeah.
Well, I may provide my perspective. Yeah, I think this has been a topic throughout the whole week. How can we closer collaborate between the pilots and GGCMI? I think this is something we can learn from this response. Just to comment on this outcome of +6%, that's actually the mean of the model. So there are some that show a large increase, but there are also many that show a large decrease for wheat. And that has also been a topic. How can we ensure some kind of quality control within such an ensemble? And for that, we have already been discussing, we may need some kind of quality indicators from the field scale model, like specific response curves, so that we don't necessarily need to participate directly in all the pilots, but that we get some information in a specific agro-environment. What would be a typical temperature response within the pilots for wheat or for maize, so that we can basically get an orientation and maybe also figure out what would be a sanity check for those global gridded crop models. So that's basically the self-learning internally, I would say, what we can provide based on these outcomes to stakeholders, if that is the question. That's also a question that Christoph has posed already on Tuesday, I think, like when it comes to science policy communication and the uncertainties like that. What can you actually say about this? So that's then a different question.
In fact, Alex, I remember a slide you put up several years ago on uncertainty by different models. No? So the uncertainty at the climate model level, at the GGCM model level, at the economic model level, and it would be good also to track this. I don't know if this is exactly what you meant with this, but they will be good to look at this, especially whether we have been able to reduce the uncertainty in crop growth models. Because to be honest, all the analysis I've done on extremes and on long-term climate change impacts and so on, we have been able to combine a lot of GCMs, but not GGCMs, because then we are basically hiding in the mean huge discrepancy. So maybe we would take DDSAT and then we would take nine GCMs. But so it would be good to be able to use more crop growth models in parallel, but then we have to be able to reduce uncertainty or explain the uncertainty.
Yeah. Go ahead, Alex.
Yeah, just very quickly. Yeah, very, very important points. And yeah, that was from my CGRA study, I remember. And yeah, we haven't really talked about it in here yet, but the exogenous productivity trends that are used in global economics models are also very ripe for us to provide some more kind of agronomic insight about limits of adaptation and productivity trends and some of those things, and also whether they are applied globally or with regional and system kind of level contexts would be another thing that I would be very interested. So yeah, we haven't talked as much about economics, but some of the assumptions in those models are also huge. And I would say starting with the fact that most of those models are equilibrium based and may not represent volatility, even in its long-term effects in the way that we would like.
Yeah, that's it. Yeah, sure.
Yeah, so I think here the challenge might be, for example, if you take the response of crops for climate change, the different agronomic practices. I think, for example, if you say the temperature is increasing or the ozone is increasing, there is a drought in the future. The physiological mechanism of most crops are not represented in most models. For example, we can find some reasonable results for wheat, maize, but not for pulses, for example. So I think in my view, we need to have some experiments, like controlled experiments, that shows the response of most crops for climate change, for carbon dioxide, for temperature, and for drought. We have some for wheat, maize, but not for all crops. That might be one of the challenges.
Like have a I completely agree. Like have a more very highly detailed model platform, so to say, on wheat, maize, and then have some kind of a lower level modeling with less parameters and maybe less spatial differentiation, but for all the crops, or at least for most of them. That would be very helpful. And what you said, Alex, on the productivity trends, this is you're totally correct. And when we've done the Lancet 2.0 study and we had all these productivity shocks, I was wondering at some point, and I don't think anybody's really doing some implementing here some kind of constraints on agronomics or some constraints on even environmental protection policies that are in place and things like that.
Well, I'll give you my perspective for Brazil about climate change impact. I guess I'm much more pessimist. I'll explain why. Usually, at least I don't know what's going on in your group, but I'm talking about the papers that is published in Brazil about the climate change impact. Most of the studies they evaluate a crop in an isolated way. I have many papers. Oh, what's the impact of climate change in soybean? What's the impact of climate change in maize? And is taking place already in Brazil, and the projection from climate projections is that probably we are going to delay the rainy season, and probably we are going to have 1 month less. And if you have 1 month less, that means that will be not more possible any longer to produce soybean and maize. It's not possible to evaluate the impact of climate change for soybean and maize in isolate way. You have to evaluate both together. This is totally different. Because if you lost 1 month but evaluate soybean, that's okay, just displace 1 month. And if you does not consider the displacement of soybean, that's okay. We will still have good weather, just planting early. But when you look both together, these impact will be much higher than what we expect. And about structure of crop models, also I guess they are underpredicted impact of climate change. And the reason is that usually most of models they use the weather station or the information of the climate that come from the global climate model or any models. And actually, when you have, for instance, a drought, the plant is not any longer feels the temperature in the weather station. The temperature the plant is feeling is much higher. For instance, for rice, we have a problem of sterility. But if you put like the temperature for the station, actually the temperature the plant feels much higher. So these models needs to evaluate and to predicting the temperature of the plant and not use the temperature of the air at 2 meters in a weather station.
Yeah, we could continue, that and go a little bit beyond and talk also about perennials, right? Because that's another story. For example, for coffee, I was discussing these days. The problem, for example, if you have a big drought or a big frost, for example, will impact coffee. Usually that's happening in Brazil in 2021. Usually that destroy coffee areas that are only going to produce again in 3 years from now. So, and then it changed completely how you assess the impact of climate change, right? Also, we have this, and I usually, for example, for coffee studies, they consider the impact of productivity in yearly, but they don't consider these impacts on area that are destroyed and takes another 3 years to recover, which can be dramatic in some situations. So, yeah, just to mention this. So, yeah, Alex, go ahead.
You can correct me if I'm wrong, but I think we're about out of time and have to get back to the main session. So I'm going to make this my final word, which is to say we are in a delicate position in this because in a high funding environment, if there were funders in the room and we identified things that we could be doing better, they might say, here's some funds, fill in the gap. And then next time the projections will be better and everybody wins. Unfortunately, I don't know if there's any funders in the room. And that means that we are in the position of trying to alert people about the weaknesses in our model, which might make people not want to use our models. And we, I think, all are here because we understand that process-based models have the highest ceilings. If we do them well, they are better than empirical models. They are better than machine learning. They are able to go to new environments. All of those things that draw us here are absolutely true. And we have to be able to talk about what we do and don't know, what we do and don't do well, and also manage to do it in a way that does not scare people away from taking on this challenge because the potential is so high for what we might be able to find out. So I'll leave that as my last word, is we have to be able to be honest, be open, but also keep the story around how we want to do better so that we can make bigger impacts and benefit more people. Thank you.
Yes. You want to mention something? Yeah, I don't know. I mean, my agenda here, I don't want to keep everyone here, but it was supposed to finish 5, I think. So maybe I'm wrong. Yeah. If anyone has another comment, we can take. Otherwise, we could go for coffee.
We are probably okay now.
Yeah. So then,
Roger's been taking notes. I will try to complement, and Alex, we can share the notes later and try to find those elements. I don't want to consider myself a funder, but I do have some say into the Horizon Europe projects.
Great. And Roger, I think you're right. I was looking at the wrong thing. So if you have more time, please don't let me stop it early. Maybe we'll just get some final comments from others in the room, and then we'll have time to get back to the main room.
yeah. So any other comments or not?
One thing that I didn't see is fire. Fire is start to be fire used not to be a problem in Brazil, but now unfortunately it start to be a problem. And this is very important, especially for perennial crops that has a lot of money to recover. So eucalyptus, sugarcane, coffee, and
satellite.
But for climate projections, we need the crop models.
Yeah.
We need the crop models to do those projections also.
When you do climate change projections, right?
You need
For crops productivity, I mean, we should in a way be considering, I mean, also the incidence of fires, right? And the incidence of many other things that can impact, even, for example, as I showed here, even price spikes that change completely the behavior of the farmer, and so the question would be, with the tools we have right now, probably we can already simulate very well the crop system and its impacts in future. It's just a way, how can you combine these tools in a way you have, and I mean tools, I mean satellite images, but machine learning models outside of crop modeling techniques, models of farmers' behaviors, economical models. How could we create an environment that we can combine all this together to have projections? Maybe bring, for example, I'm pretty sure there are studies that have projections for fire incidence in future. How can we bring this in the GSMI studies? So how can we bridge this team, construct this team? Yeah.
Well, just to again share our own perspective on this, because I come from a team where we do agricultural modeling, forestry modeling, and fire modeling, all 3 of them together. And we also try to combine those, but we know that fires 90% are anthropogenic. So we typically don't need, we have been discussing whether we need crop residue as a fuel, really as an information for the fire model, but basically the fire is coming to the crops or it's basically the starting point for the fire is the field, but it's a human activity, and then the biomass doesn't matter and it goes to the forest. So in brief, our approach here is to do an offline coupling, and you can simply do an overlay of the fire projections with the cropland. That works fairly well. And there's another community to hook up with. And there's within AgMIP that many may be aware of. There's also the FireMIP project where they run different fire models globally. And this would then be a source of data from which you can do overlays herein. So this would go into this domain where we can do offline coupling with specific models where we don't really need this feedback within the two domains necessarily.
Yeah. So any other comments? So what do you think? You think just looking at the some questions you have there. So is it necessary to have a new team in AgMIP? You have enough. How can we put the AgMIP community to try to tackle these problems we are having now? So it's again this philosophical question that was many times around, but maybe we could try once more. What can we do to have better projections for future? And in one day, if a president of any country comes to us and says, "Give me some projections for future," we are more confident to give better results. So
I'm going to jump in from over your shoulder here just to say it would be very interesting for us to figure out a way to write large community papers. You see this in some other communities where all of the modeling groups come together on one big paper for the sense of the community or the research agenda for the community. Something like that could be a high-level nature food commentary or even some other place like that. It might be worth us coming out of not only this radical collaboration session, but perhaps others, and establishing a way for us to have a process where we write this paper with large-scale opportunities for input from the AgMIP community. I'm not sure we can have 1,000 authors, but we could certainly have like open forum for inputs that we could then link into a paper like this. Thank you.
Yeah, that definitely would be a very nice start. I agree. If you could, organize the team and start organizing these ideas of how to make these simulations more reliable in a paper, bring people from different perspectives that we have already in AgMIP, that maybe would be a very nice start.
Alex, from the experience of the Lancet 2.0 effort, it's amazing the amount of bugs that you fix and the amount of work you put into the model behavior just by doing the exercise. So doing a large horizontal exercise or by the crop growth community, or we do something on crop systems, something like that, involving everybody or a lot of the models that are in this community, it will help a lot to bring them up to speed. This is just kind of a demand-driven approach.
Okay, so any more questions, comments? Oh, I think you should go and get a coffee, maybe. Okay, thanks, Alex.
Thanks, Alex.
Thanks, Rogério. Thanks, Ignacio.
Good.
What kind of maybe people like select like the 10 main points in the market.
Yeah, right here what is said, but so they said about weeds, hydrological models. There's some comments about coupling hydrological models with crop models. Fire models